Exploring age dependency ratios in graphs. It really should just be in graph. We just have the one. So anyway, we're going to look at this. We have dependency ratios from 1945 through the projected 2095. All right, starting things off. What does the horizontal axis represent? Because remember, when you're using graphs, you first want to just see what are you talking about. So the horizontal axis is years from 1940 all the way through roughly 2100. What does the vertical axis represent? Well, you'll notice these are per 100 persons of working age. So per 100 workers, and this gives us the number of dependents. So this is the dependency ratio of the number of dependents per 100 workers. That's what it's looking at. So just to kind of clear it up here, if we're looking at this one here, it's a circle. So we're looking at age dependency ratio. It looks to be about, what, maybe 11. So it'd be 11 over 100. So 11 dependents for every 100 workers. That's how to read this graph. Let's look at number 3. Use the graph to approximate the 2021 youth dependency ratio. Well, the youth are the diamonds, I guess, and we're looking for 2021. So 2021 is going to be just past this. So we're looking at like right here. So then if I put myself over here, I can go, I don't know, maybe 41, 42, 43, somewhere in the mid-40s. Let's use 45 just for fun. But somewhere between 40, 45, somewhere in there. Okay, because this is youth over 100 workers. So that's what this means. Now, assume it was calculated that the child dependency ratio is actually 0.285. That's out of 1. So if we wanted to change that to 100, we'd multiply the top and the bottom by 100, and we would get 28.5 over 100. How does this compare with what we just had? And remember, the answer that we just looked at was roughly 45 over 100. So you're told this is the child dependency ratio, and we found, wait, this is the child. We found that the youth dependency ratio from this graph is roughly 45 over 100. That's actually a pretty big difference, right? That's like 16 and a half kids, 17 kids. That's a lot. So let's look at this. The data used to create this graphic defined youth as those under the age of 20, and working class is 20 to 64. Traditionally, child dependency ratios are found by taking 0 to 14-year-olds over the working class of 14 to 64. This table called it youth and not children and said 0 to 19, and workers are 20 to 64. So you can see how that age group of 15 to 19 shifted from workers in the child dependency ratios to youth in this youth dependency ratios, and thus we have the big difference. Because if you're moving an entire group of people out of the working class and into the dependents, we're going to have a higher dependency ratio, right? That makes sense. So that's the big difference between a child dependency ratio and a youth dependency ratio. So what trends in youth and age, when we say age, this is old, right? Old people. And total is the youth plus the old. Okay, so what trends in youth and old people? Youth is here. The red is youth. And the black here is old. So, what do we notice? Well, the youth is stabilizing, starting in about, I don't know, 2020-ish. Around 2020, the youth stabilizes, stays pretty consistent. Whereas the aged, starting in, Well, it's kind of increasing. It continues to, and it's expected to continue to increase. And eventually, right, long-term prediction, the youth and the aged become pretty much the same. They're both stabilizing to be right around that 45-ish, 45 out of 100. So that's kind of just, well, it's kind of rough that the prediction, if you look up here for the overall, it's close to 90 over 100. So for every 100 workers, they are supporting 90 dependents. And if that actually happens, that's going to be hard for the working class to support all of those. But if you think about it, this comes to like the baby boomer idea that we have all of these people getting old at the same time, which is going to put an economic burden on those of the working class. At least that's the anticipation and the expectation.